Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, so the 2018 question, it was question 1 of paper 2, looks at expected value. So in a competition, Mary has a probability of 1/20 of winning, a probability of 1/10 of finishing second, and a probability of 1/4 of finishing in third. If she wins the competition, she gets 9,000. If she comes second, she gets 7,000. And if she comes third, she gets 3,000. In all other cases, she gets nothing. Each participant in the competition must pay 2,000 to enter. Find the expected value of Mary's loss if she enters the competition. Okay, now, in fact, this isn't a bad old question once you have the little bit of theory. So the important theory here is, how do we calculate expected value, always called E of x? Well, it's the sum of, so that's the Greek letter, sum of all of the values of x by the probability of x occurring. Okay, so take down that, make sure you know it, because that's the piece of theory that will help you with the expected value questions. Now, what does it mean? Okay, so for this one, the expected value means sum just means add, x is the values and p is the probabilities. So the first value, or the first amount she could win, is 9,000 euros. Okay, so I have 9,000 euros by the probability of her winning that. So the probability of her winning is 1/20. Okay, sigma tells me to add. Okay, well, what else could she win? She could come second. So she could win 7,000, and the probability of her finishing in second place is 1/10. Or she could come third and she gets 3,000, and the probability of her coming third is 1/4. Okay, so this is the expected value that Mary could win in this competition. Okay, so I'm going to the calculator and I'm just putting that in now. And I'm getting 450 plus 7,000 by 1/10 is 700. I don't need that one. Plus 750, I believe, for this one. Add those up. Okay, so the expected value is 1,900 euros. Okay, now I remember the first time I saw expected value, I would have been confused by that amount, because that is not one of the values she could win. So it was 9,000, 7,000 and 3,000. Okay, and yet I'm getting the expected value that she could win is 1,900. Okay, so expected value is not an actual amount in the competition. It is statistically, or the probability, the amount that she could win given the above data. Okay, so very useful for the likes of this, for competitions, to see on average how much would whoever was holding this competition pay out. So on average, they would pay out 1,900 euros to each person that played this competition with those odds. Okay, and they use that information then to set the entry fee for your competition. Okay, so each participant in the competition must pay 2,000 to enter. So if you're paying 2,000, but on average you're only winning 1,900, then can you see then that it's a loss you would make of 100 euros. So on average, every game that's played would result in a loss of 100. That's a loss to the person playing the game. This question could also be asked in a different way, which would be from the point of view of the company hosting the game. So the company hosting the game would make a gain of 100 every time someone played the game. Okay, so it's a very good competition from whoever is running the competition. It's a poor one for whoever enters it. No, I'm not saying that people won't make money. Yes, of course you can make money. You could make 9,000 euros, okay? And you have a 1 in 20 chance of doing that. You could also make 7,000 or 3,000. But what I am saying is that on average, people will only ever win 1,900. So that's what we use things like the expected value for. Okay, so that was part A. Then part B. Each of the 3 prizes in the competition above is increased by the same amount, X, but the entry fee is unchanged. For example, if Mary wins the competition now, she would get not the 9,000 up here, but 9,000 plus X. Mary now expects to break even. So whoever's hosting this competition wants to make it be, maybe it's a not for profit, so they want you to have break even. Find the value of X. Okay, so we want to increase each of the prizes by X euros. So now our expected value of X would be 1/20th of 9,000 plus X, plus 1/10 of 7,000 plus X, plus 1/4 of 3,000 plus X. And we want to break even, so we want our expected value to end up being 2,000. And I need to solve this for X. Okay, well, I have some of the maths done because we already got 1/20th of 9,000, it's there. We got 450 plus 1/20th X plus 1/10 of 7,000 is 700 plus 1/10 X plus 1/4 of 3,000 is 750 plus 1/4 X, and that's equal to 2,000. Okay, I'm going to bring these amounts all over the other side, and you'll find out that you get 1/20th X plus 1/10 X plus 1/4 X being equal to 100. Okay, because they're going to add up to 1,900, the same they did here. Let's factor out our X so that it only appears once. And onto my calculator, I'm going 1/20 plus 1/10 plus 1/4, and I get 2/5 is equal to 100. Divide both sides by 2/5. So 100 divided by 2/5, and I get X being equal to 250. So then I have a little look up here to see what was the actual question. It was find the value of X. I was wondering, would it be find the new prizes? But no, it's find the new value of X, which is 250 euros. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice? In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.